Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the starting material. The starting material is a cyclopentanone with a stereogenic center at C2 bearing a co-2-ate group on a wedge bond, defined absolute configuration, a single enantiomer. Step 2. Understand what Lyell-4 does. Lyell-4 reduces both the ketone, C is equal to O at C1, and the ester, co-2-ate at C2, to give the corresponding alcohols, C1 ketone C1O, and co-2-ate CH2O at C2. Step 3. Analyze stereochemical outcome at each center. At C2, the configuration is already set, wedge bond in starting material. The reduction of the ester, co-2-ate to CH2O does not break the C2-C bond, it converts the ester carbonyl to CH2O while the stereocenter at C2 retains its configuration. So C2 remains a single defined stereocenter. At C1, former ketone Lyell-4 reduces the cyclopentanone to give a new stereocenter at C1. The hydride can attack from either phase of the planar ketone, but the existing stereocenter at C2 creates a diastereotopic environment, meaning the two phases are not equivalent. Facial selectivity is not necessarily 50-50, but more importantly the two outcomes give diastereomers, not enantiomers. Step 4. Identify the nature of the product mixture. Because C2 is a fixed stereocenter, from the optically pure starting material, and C1 becomes a new stereocenter upon reduction, hydride attack on the two faces of C1 produces two products that differ at C1 but not at C2. These two products are diastereomers of each other. Step 5. Eliminate other options. A. Racemic. A racemic mixture would require equal amounts of two enantiomers. Since C2 is fixed, the two products formed differ at C1 only and are diastereomers, not enantiomers. So the mixture is not racemic. C. Meso. A meso compound requires an internal plane of symmetry that makes the molecule achiral despite stereocenters. The cyclopentane ring with O and CH2O substituents does not possess the necessary internal symmetry for a meso compound here. D. Optically pure. Optically pure would mean a single stereoisomer is formed with 100% stereoselectivity at C1. Lyell-4 is not stereospecific enough to guarantee complete facial selectivity, and the question implies a mixture is obtained. B. Diastereomer. The reaction produces two products, cis and trans isomers of the 1-hydroxy,2-hydroxymethyl, cyclopentane, that are diastereomers because they share the same configuration at C2 but differ at C1. Therefore, the correct answer is B. Therefore, the correct answer is option B.